Welcome. In this video, I'm going to talk about low-level container debugging, Docker containers. And the reason why you might be interested in this is you have a container that's just outright dying or faulting, and you're not getting a lot of information about it. The techniques that you see in this video should greatly help you understand what those issues are. So first things first, we have a test project that we're going to use to trigger an error, and just to kind of show at first that the project runs normally, I'm going to go ahead and start it. We're of course using Visual Studio here, and the basic project flow here is pretty simple. We're going to go in, we're going to load a web page. It's going to hit a call, which is out to our database context. If everything's working right, it should return a single result, which it has, and then return the world's simplest view right here. One thing to quickly point out, if you're new to Docker, is just because a container, if we look at our containers here, is running, doesn't actually mean that the thing that's within the container is running. This is one of those concepts I always like to sort of make sure that folks know as they're starting. So in other words, if I stop my debugging session here, if I reload this page, site can't be reached, but the container is still running. And so it's always important to think about containers as a thing that contains something else that you want to be doing something. In this case, running a web server. And just because the container is running doesn't mean the thing inside is also running as well. And that's especially true when you have a local context like we have right here. Let's go ahead and break this application now. I'm going to do it very deviously. I'm just going to literally change my connection string here. These are both valid, by the way, connection strings. Unfortunately, this connection string is going to trigger a catastrophic error in our container. So once again, we'll try to load the site. We'll hit our breakpoint, but now notice the container's running. When I load this line of code, it's going to literally kill the container. So container is running, but the actual the web server within has died again, or it's died. And unfortunately, we don't have a lot of information as to what happened. We quite literally have no information. We just have an informational message here saying that we had started NAD framework. So what do we do about this? So the first thing I'm going to do is I'm going to change the build context of my application. So let's just go ahead and keep things clean. I'm going to literally delete that container. I'm going to delete the image as well, just so we can kind of start fresh with everything. And what I'm going to do is in the file system of this project, and this is, again, specific to Visual Studio projects, but when you generate a Docker file or Docker support by right-clicking on your project and saying Add Docker Support, one of the things that it does is it generates this Docker file, and it places it adjacent to your CS project file. What I'm actually going to be doing is copying that file one level up so it's adjacent with the solution file. I've already done that right here. Let me just kind of show it to you real quick. The reason why I'm doing this is because I want to create a clean build environment from this. And just to kind of show you it's possible, but not recommending that you do this in most cases, I've actually changed the image tag that's being used. So we actually pull from an Alpine-based image as opposed to an Ubuntu image like we would right here. And also to point out then that one thing you do need to be careful of as you're working with Docker files is the different operating systems often have different requirements. And one of those, in this case, for example, is when you're calling into a database and you're using an Alpine-based image, to keep these sizes small in these containers, they actually removed some of the critical components that you need to run database connectivity, in this case, having to do with system globalization. So we need to run some commands and set an environment variable so that we add that functionality back in. The reason why I'm bringing this up is because sometimes when you change operating systems, you can introduce more errors. So use this very carefully and make sure you know the consequences that you're using. And to be clear, the reason why I'm doing this video is because some of the tools we're going to install in the container go much faster within Alpine. If I wasn't doing this video, I would leave the base image the same. So with that said then, what I'm going to do now is I'm going to copy this location and in PowerShell build my image. So as you recall here, we deleted that container and we have no images in the system. So we'll just go ahead and build it. There's our image, and then we'll run that container. So paste it in. Quickly, to explain this command right here, this is Docker run. This is how you start an image. We're not doing anything too special here. We're simply doing some port mapping. We're running interactively, and then we're mapping some SSL certificate information. That's what these guys are. If, by the way, you're stuck on SSL, these variables will definitely help you as you get that set up. And then we're just simply saying you're going to run this container with this tag. So when we do this, the application will start. We actually map this now to a slightly different port than what we had before. So I'm actually going to go to that port, close these other two guys up. And you'll notice now that we're going to fail catastrophically. So we're going to load our site, and we fail so incredibly that we literally shut the container down. If we look here under containers, you'll see the container is exited. So in a production environment, unlike we had in Visual Studio, which had sort of like this, no, you keep running no matter what, you would just kill the container. And then usually your orchestration layer would start the container up again, but if you hit the code, it would kill it over and over and over again. So how do we fix this? Well, again, it all comes back to what do we actually know? And at this point, we know pretty much nothing. We just know that we end with this informational line right here. So we need a slightly better way of getting information from this container. And that's why we did this right here, because the first command that we ran didn't give us quite what we needed. But if we expand on that command just a little bit, we're going to get a much more debug-friendly container. So this command is almost all the same until we get to this part right here. This is going to create a core dump, which is to say if your container dies, the operating system is going to take a snapshot of the failed process and save it so you can inspect it later. We have this privileged command here, which assists with that. And then most importantly is this line right here. So what this is saying is that in the normal way of running a Docker container, we're going to respect what the Docker file says is your entry point. In other words, you want to call the .NET function and run this, in this case, DLL. However, here we're actually saying, no, your entry point is a shell. And that makes all the difference when we run this, because now when we do that, we're going to return immediately, but if we go to Docker Desktop, select that container, and open up a command prompt, now that process, the process that's failing, can be started manually and it can die all at once, and it's not going to take our container down. And that is absolutely critical for determining what the actual error is. And so there's a couple different things that we could do with this. Now we start with the base knowledge that in order to start this .NET application, we're going to simply say .NET and then the name of that DLL. So really the exact same thing that we're saying here, .NET container test.dll. If you're ever confused about how you start your application, check out the entry point first. I usually tell you what you need to know. So if I do this, you'll notice the same general log output that we had before. But if we trigger a failure, as we are getting before, now you're going to notice different output. So look at that, segmentation fault, core dumped. So the core dump, again, came from the command line prompt parameter that we put in, but also now we actually have something a little bit closer to go on. It's still not helpful. If you know what a seg fault is, it's not telling us much. It has to do with memory usually, but at least it's better than this down here. So we can actually do better though. So what I'm going to do is I'm going to copy in a command that's going to install some packages. And let me just try to get this in. There we go. So APK is the name of the package manager on Alpine, and we're going to add the GDB, LLDB, and strace packages. And again, the reason why I'm using Alpine to do this is because this is much, much faster on, there we go. This is much faster on Alpine. So that's why I did it here. On Ubuntu systems, this will take up to 5 minutes. Here, very, very quick, as you can see. So now that we have those packages installed, we can do something really neat. We can say, I have the GDB debugger. So how about GDB, you run the .NET application? And then further, how about you run the container.dll application? And now that we do this, you can see here, same debug info that we had before, but if we run our application, And sometimes this can get a little bit funky if you've had other requests in the pipeline. We may have to actually break, which I'll show in a second if it does come down to that. You can see here that it's trying to load and not quite doing it. If I hit period, it'll usually cause the debugger to stop at the faulting location. And so now for the very first time we have something useful, which is it has faulted at this function. If I copy this and just say Docker and the name of that function, it takes us literally to exactly the place where this is being discussed. So this is why this technique really, really handy. Now we can actually go one step further with GDB, or excuse me, with LLDB. So LLDB, another debugger, but it's usually a little bit better at handling managed code like what .NET Core is. So we can say the same general thing, LLDB.NET, but this time we can say process launch, and then we can say container test.dll. And it's going to do the same thing, but as you'll see now, it's a little bit more detailed with its output. And I find usually a little bit more reliable at triggering the error without having to press the period button. So here you can say general thing that we had before, it's giving us that faulty function name right here, and it's even giving us a little bit of a sort of like a stack trace of what was happening beforehand here. In this case, just some assembly. So with that done then, hopefully you have some of the tools that you need to debug and investigate these more tricky issues within your containers. The last thing I'll kind of say is if I was running containers in a production environment, one thing I would want to do is I would want to make sure that if I have these crashes happen, that I have some record of what that crash was. And those core dump files is one way that you can do that. Now, you generally need to take them out of the container so that they're not destroyed if the container is destroyed. But if you map an external volume, you can take those core dump files, put them in a safe location, and then you can use these debugging tools to get into that container and try to find out what happened, or at least have a better version of what happened rather than just no information or seg fault. So with that said, we're done. Questions, comments, please let us know below.